This is a tour of a slitting saw project I undertook in an effort to come up with an affordable, simple, low-tech way of turning blank PVC casing into well screen with precision slots and lots of open area, but at a technology level that could be fabricated and maintained in an Ethiopian village setting. And I'm now abandoning the project, and I will tell you a little bit about why. But here is the slitting saw. You'll notice first it's on a plywood table. They don't have plywood there, I don't think. Notice the 4x4 legs. The original 2x2s were too wobbly, and any kind of vibration disrupted the sawing process. You can put a 3-meter or 10-foot length of 4-inch PVC pipe in this rack. The rack has welded on bracket holders for wheels that the pipe rests on, with different settings for 2-inch, 3-inch, and 4-inch pipe. 4-inch is the one I expect to use the most, but also has proven to be the most difficult because the saw blades exert a lot of torque on the pipe, and it's hard to manage the pipe. So the mechanism needs to be able to rotate the pipe while moving saw blades in and out of the pipe. And then after going around the circumference, doing 4 rows of slots, then shift the pipe down an inch or two, and then do it over again. So here's the pipe rotation mechanism. This is just a pulley with a handle. It turns a bigger pulley that goes through the housing, picks up another pulley on the other side that comes up, and with a V-belt just straps around the pipe and turns the pipe. You have to be able to release this belt in order to shift the pipe downward. So there is a counterweight under the, which is at the moment just a paint bucket full of rocks. And by pulling on this string, you lift the paint bucket up. It's got a stop knot to hold it. That loosens the belt enough that you can slide the pipe down. And so here's the rotation mechanism. That works all right. Aligning the sets of pulleys to hold the pipe in the straight line was a little bit challenging, but at the end of this long extension, I have legs that swivel and pivot, so you can just manually line it up till the pipe is resting on all of the wheels equally. Here is the guide mechanism for turning the pipe. It looks kind of kludgy. This draw pull catch on a collar was an attempt to keep the pipe from shifting downward as it turned around the several rows of slots. By the time I got to the end of a circumference, the pipe had shifted down by half a centimeter or so, and this was an attempt, not completely successful, to keep the pipe from shifting while it turned. It turns out that alignment in all 3 directions between the pipe and the saw blade axle is extremely critical and a little difficult to do with primitive tools and gap measurements. And that turned out to be a problem because any misalignment binds the blades, and then that grabs the pipe and blows out a big piece of plastic. Here's the mechanism to pull the saw in and out. It's a string that goes through the housing around a pulley, so it's got a 2-to-1 advantage. That pulls the whole saw table in and out. The saw table is on heavy-duty ball bearing drawer rollers, and the back has strings that go through the housing down to some counterweights in the back that pull the motor back. Here's the power switch. It's wired to an outlet that the motor plugs into, and then this gets power from the wall. It turns on, and here you can see the apparatus moving in the latest attempt to improve action where I wanted to reduce the pulley, the saw blade speed. So I put a central pulley that required a whole second axle with its 2 bearings. And it turns out it didn't solve the problem. Instead of delivering more power at a lower speed right at the saw blades, this second belt just tended to slip and the pipe would stop the saw blades. So after this latest failure, I'm kind of abandoning the project. But you can see here how the blades move towards the pipe when you pull the string, and then you can turn the pipe with the other handle at the other end and proceed to make your 4 rows of slots. Now I have a face guard, and there's a housing that goes over these pulleys for additional safety protection. That's about it. The problem ultimately was that the saw blades would tend to bind in the plastic pipe as it was turning in such a way that they would blow out a piece of plastic, or you could tell by the sound that it wasn't safe to be advancing at a reasonable rate. And so overall, this whole thing has become way too kludgy and fussy to be a reliable and inexpensive way of making precision slots in plastic to make well screen. So I'm going to recommend going back to the good old tried and true hacksaw method in the field.